Okay, so we're going to go through your October holiday, like half-term homework. Right, so for question 1, we had to write down an equation which describes the relationship between x and y in each of the graphs below. Right, so this is basically, these ones are just a reminder from National 5. There's nothing here that you shouldn't have been able to do before that point. Right, so it's going to be y equals the shape of the graph, because it starts at 0, goes up, comes down, is a sine graph. So we know we've got to have sine. We have one wave in 360, so that means that it's just sine x. It's not sine 2x or anything, because that's how many waves there are. And because our magnitude is 4, like our graph goes up to 4 and down to -4, we can say that we know that our amplitude is 4, so that is the answer for part A, is y equals 4 sine x. Right, so for part B, it's still y equals this time, because our graph starts at our maximum and then goes down. We know that it's going to be a cos graph, right? Because we've got one, because that's one full wave going down, 1. We've got 2 waves in 360. I don't know why I've written 3. It is in fact 2x, and because our maximum and our minimum are the same and they're 20, our amplitude is 20, so we get 20 cos of 2x for part B. And then for C, right, our centre of our graph has been moved, so it's been moved up 2, so we know we've got to have a +2 on the end. Right, so our graph from where our centre is goes up. It goes up from there to our maximum, so that means that it's a sine graph. Right here, we've got 1, so that's 1 wave. We've got 2 waves, but that's in 180. So in 360 we would have 4, so it's going to be 4x. Right, and our amplitude is how far it's gone from our centre up. So it's gone up 4. So that means our amplitude is 4. So we've got 4 sine 4x plus 2. Okay, so on to question 2. Right, okay, so we've got the graph of f of x, which is shown there. And we need to draw a sketch of, there's 4 different sketches we need to do. Right, so for part A, if we've got to sketch y equals negative f of x, what's going to happen there is that's reflecting our graph in the x-axis. So like our y values become negative, so our coordinates are -3, 0. Put these up here as well, -3, 0, just so they're there for all of them. And we've gone 0 along and 4 up. Right, so with negative f of x, that one's going to stay the same, but this one's going to become 0 and -4 because we've changed our y coordinate to be negative. Okay, so our graph, we've got these points. I know I normally draw the axis after, but I want to just make sure that this one goes through the right points. And sometimes when it's doing it this way, it can be easier, like when you're flipping it in an axis, because the shape's not quite the same, it can be easier to draw it first. So we know we're coming up from the negative, going there, kind of curving, and going on. So that's that graph, first one, A. So for B, we have to draw a sketch of y equals f of negative x plus 1. Right, so we're starting out with -3, 0 and 0, 4. So we always do what's in the brackets first. So what does that do? That makes our x coordinates change sign. So we end up with 3, 0 and 0, 4. So this time we're kind of flipping it in the y-axis instead of the x-axis. And then we need to add 1 to our y coordinates, so we get 3, 1, and we get 0, 5. Right, so again, I'm going to draw the axis first for this one. It just really does depend on the graph whether I'll draw the axis first or not. X and y, so we've got somewhere here we should have 5, and then we're going to have 3, 1. Right, so our graph is going to start up high, come there. It can be quite hard to sketch the shape of the graph, and then come down like that. So it can be easier to draw like little tiny lines that make kind of one line rather than drawing it all in kind of one go. So that is part B. So hope I have space for all these. C. We've got to draw y equals f of x minus 3. Right, so we start out with minus 3, 0 and 0, 4. Okay, so what we do is we add 3, because remember if it's in the bracket it's doing something to the x, it changes it. So if we add 3 to 3, we don't get 3. We definitely don't. We add 3 to minus 3, we get 0. So we're going to have 0, 0, and we're going to have 3, 4. So we've just added 3 to both of those. So our graph is going to be exactly the same shape. But it's going to go through the origin here, and then a point of 3, 4. 3, 4. Okay, so our shape is going to be exactly the same, comes up like this, and then curves its way up. 2, 3, 4, and keeps going. Make that a wee bit bigger to make it a bit more obvious, and that one a wee bit bigger to make it a wee bit more obvious. Not forgetting to write our x and our y on our axes every time. Okay, so D, we have been asked to draw y equals f to the minus 1 of x. Okay, I know we'd only just done this kind of before the holidays, but what this is a graph that's reflected in y equals x. So what you do is you need to change round the x and the y coordinates. So you've got minus 3, 0, and you've got 0, 4, and those become 0, minus 3, and 4, 0. So it's like the difference between a log and an exponential. You have 0, 1, and then you have 1, 0. So graph again. So we have a graph like this. Again, it can be easier sometimes to draw the points first, because then it kind of gives us a reference for how our shape's going to go. So this is a graph that's reflected like in this line here. So it's like symmetrical about the line y equals x. So we should have, if I've got this 4 minus 3, which looks like this. Right, so starting kind of, this is where things can get a bit tricky. So we know that we've got to curve our graph, sorry, I'm like, yeah. Start like that, curve in like this, and then curve that way. So you can see that it looks kind of symmetrical about that line y equals x. It doesn't need to be exact, especially I've just drawn it there. I've drawn the original graph as a kind of way to show you that it's a reflection of it, but you don't need to draw the original unless it asks you to. Right, okay, so on to question 3. This one took a wee while, but don't worry. Okay, so we've got to express square root of 3 cos x plus sin x in the form, so it's equal to k sine x plus alpha. So we get k sine x cos alpha when we expand this, plus k sine alpha cos x. Right, so that's the expansion from your formula sheet, which you should all have a copy of. Right, so we equate our variables. So we have root 3 cos x. Oh, I've got an x in that bit. That equates to the bit that's got the cos x in it, so we get k sine alpha cos x. Cross out cos x's, so we get k sine alpha equals the square root of 3. And then we get k cos alpha equals 1 from like the similar kind of thing that we would do, but not going to go through it. Right, so we then get that tan alpha is equal to k sine alpha over k cos alpha, which in this case is root 3 over 1. So from our knowing our exact value triangles, I can't really express how important it is to remember these, right? It's got degrees, so we know it's degrees, so that's 60, that's 30, we don't have to work with the radians this time. Right, so we've got that, and we have tan alpha is root 3 over 1, so that's opposite over adjacent. So opposite, and that's the adjacent, so we know that alpha is, well, the inverse tan of root 3, which is 60 degrees. Okay, and then for our k, finding our k, we know k is equal to k squared is equal to the square root of 3 squared plus 1 squared. Okay, that's kind of cutting it short, but we know that kind of k squared sine squared alpha plus k squared cos squared alpha equals the square root of 3 squared plus 1 squared, and then it kind of ends up as this. So we get the square root of 3 plus 1, which is the square root of 4, so it's 2. So therefore, square root of 3 cos x plus sine x is equal to 2 sine x plus 60. Right, so for part B, we've been asked to state the maximum value of the function of f of x given the f of x equals all of that. So we've got f of x is equal to 1 over, replacing it with what we just found, 2 sine x plus 60 plus 4. Right, so the maximum value of that thing we just found of 2 sine x plus 60 degrees is going to be 2, because that's our amplitude, so it's the maximum value we're going to get. So our max is going to be 1 over 2 plus 4, so 1 over 6. That's our answer for our maximum. Right, okay, so on to question 4. Okay, so question 4, we've got if tan alpha is 1 over root 5, where pi is less than or equal to a, which is less than 3 pi over 2, find the exact value of sine 2 alpha. Right, so here we've been told, kind of on our cast diagram, right, that that's where pi is, and that's where 3 pi over 2 is. So we know that it's in there, but we can kind of work out the relative acute angle and then kind of go from, like, the values for the relative acute angle and kind of go from there. Because the value is the same, it's just going to be, the cos and the sine are just going to be negative because they're in that quadrant. Right, so if we've got a triangle where we've got tan of alpha, so alpha in there is 1 over the square root of 5, we know that the other side is going to be the square root of 5 squared plus 1 squared, like the square root of all of that. So the square root of 5 plus 1 is the square root of 6. So we're going to get the square root of 6 as our hypotenuse. So we know that sine of alpha, because it's in that quadrant, we know it's negative. So it's going to be negative, and then opposite 1 over root 6. And the cos of alpha is going to be negative again, and it's going to be root 5 over root 6. Because it's in that quadrant, our sine and our cos are negative. But like we can still work out the values using the same triangle, because it's going to be the same value, like the angle is the same whether it's in the first quadrant or the third quadrant. All that we've done is we've added pi to it. But the values of sine x and sine alpha and cos alpha are the same, just negative. Right, so we then know that sine 2x is equal to 2 sine x cos x, right? You don't need to remember this, but maybe you should, as a way to make it a wee bit easier. It's on your formula sheet, but like I was saying, it might make things a wee bit quicker for you in your exam if you know these things rather than kind of having to rely on formula sheets. Right, so we've got 2 times the negative 1 over root 6 times negative 5 over root 6. So we get 2 times those together, we're going to get root 5 over 6. So we get 2 root 5 over 6, which is root 5 over 3. Right, on to question 5. Right, so this is going into the halfway mark. It's question 5, there's 9 questions, right? So we're getting there. So for A, we've been told that tan theta is the square root of 5 over the square root of 9. We've been told that theta is between 0 and pi over 2, so that's our first quadrant, so that's nice for us. So we need to find sine theta equals something and cos theta, that value. So we draw a triangle, construct one, theta's in here. We're going to have root 5 over the square root of 9. Okay, my triangle doesn't really necessarily make sense, but that's fine. It's just a sketch to help us out. So that side there is going to be 5, the square root of 5 squared, so 5 plus the square root of 9 squared, so 9. So we're going to get the square root of 14, because we've got 5 plus 9, which is 14, and then we've got the square root of it, right? So sine x is opposite over hypotenuse, which is the square root of 5 over the square root of 14, and cos theta is adjacent over the hypotenuse, so that's the square root of 9 over the square root of 14. Okay. We've been given the square root of 9, really we could change it to 3, and we will in a minute, but it's fine to just leave it like that for now, because that's how they kind of gave it to us in the question. So we need to show that sine 2 theta equals 3 root 5 over 7, just changing how we write it a wee bit. Tend not to write the fraction at the front personally, but there's no problem if you do. So looking at the left hand side, trying to make it right, so sine 2 theta is equal to 2 sine theta cos theta, right? So 2 times sine theta is the square root of 5 over the square root of 14, times by the square root of 9 over the square root of 14. So then we get 2 times, this is going to be 3 root 5 over 14. So we can then cancel between the 2 and the 14, so that 14 becomes a 7, that 2 becomes a 1. And so we get 3 root 5 over 7. You could multiply it out kind of a different way. You could end up with 6 root 5 over 14, and then again half them to get 3 and 7 to give you your 3 root 5 over 7. Either way you've done that is fine, as long as you've remembered to cancel, and that equals the right hand side. So we have proven what they've asked us to. Question 6, which is an exponential question, which is, I know, all of your absolute favourites, which is why I've put it in. Right, so we have a rocket fuel payload decays according to the formula given. M0 is the initial payload and MT is the fuel remaining. And we've been asked to find, to the nearest second, how long the rocket takes to use up 80% of its fuel. Right, so M0 is the initial and MT is the fuel remaining. Right, so what we want is to find it when the remaining fuel, 80% of it is gone, so it's 20% of that initial amount of fuel. So if 80% of it's gone, 20% is left, 20% is 0.2. So we can kind of plug that in. So we want 0.2 m0 is equal to m0 e to the minus 0.04 t. We've got m naughts on both sides, we can cancel them out. So we get 0.2 is equal to e to the negative 0.04 t. Okay, so now we can change this into a logarithm to get that out of the equation. Doing this, remember, the base of your exponential becomes the base of your logarithm. So we've got log to the base e of 0.2 is equal to negative 0.04 t. So that's just moving stuff about. Logarithm rules, should know them by now. Right, so t equals log to the base e of 0.2 divided by negative 0.04. Put that into our calculators and we get, right, so we get 40, oh, pen went a bit crazy there, 2359, right, but we've been asked to the nearest second, so it's 40 seconds. So it's not very long, is it, for a rocket to use up 80% of its fuel? Right, on to question 7. Right, so again, another logarithm question. We've been given that log to the base 2 of x plus 1 minus log to the base 2 of x equals log to the base 2 of 8. Right, so we can combine the logarithms that are on one side. So when they're subtracting, we divide. Equals log to the base 2 of 8. And then we can equate what's in our logs, so kind of cancel out the logs basically. So we get x plus 1 over x is equal to 8. So x plus 1 is equal to 8x. So take away x from both sides, which kind of move it about a bit. 7x is equal to 1. So x is equal to 1/7. Okay? Right, so question 8, we've been given that sine theta equals square root of 2 over 3 root 3, where theta is between 0 and pi over 2. Show that the exact value of cos theta is 5 over 9 root 3. Again, 5 root 3 over 9, but it's fine. So, we've got a triangle where we have theta in here, and we've got opposite root 2, and our hypotenuse is 3 root 3. Right, so we've got to find the adjacent. So that's going to be 3 root 3 squared. So I'll just give this a letter for now. Take away the square root of 2 squared. So 3 root 3 squared is 3 squared times 3. So that's 27. Take away 2. So we get 27 minus 2 is 25. So a squared is 25. So a is the square root of 25, which is 5. Right? So therefore, cos of that angle is adjacent, which is 5 over 3 root 3. Right, but we've got a rational denominator, so we need to multiply by root 3 over root 3. So on the top we get 5 root 3, and then on the bottom we get 3 times 3, because root 3 times root 3 is 3. So we get 5 root 3 over 9. Right, so on to our last question, question 9. Bet you thought we'd never get there. It's been taking quite a while, but that's fine. Right, okay, so for this question 9, the last question for your homework, we've got a scientific experiment and we've got a graph where on one axis, instead of x, we've got log to the base 10 of t, and instead of y, we've got log to the base 10 of p. So for A, we've been asked to explain why the original data takes the form p equals kt to the n, where k and n are constant integers. So the way we're going to do this is we start out with our p equals kt to the n. Okay, and we need to kind of rearrange this because what we've got is a straight line, so we're trying to make this so that we get a straight line. Okay, so the way we're going to start this is by taking the log to the base 10 on both sides, because we've got the log to the base 10 in our diagram. So we've got log to the base 10 of p equals log to the base 10 of kt to the power of n. Okay, so what we do next is we use our logarithm rules. So we've got log to the base 10 of p equals, because they're multiplied, we can add them. So we get log to the base 10 of k plus log to the base 10 of t to the power of n. Okay, so what I'm going to do here is we're just going to swap these round while we move the n down, so using another logarithm rule. So we keep the log to the base 10 of p, and it's equal to n log to the base 10 of t. So I've just kind of, as you can see, I've kind of switched that question round. Plus log to the base 10 of k. Right, so here, this is kind of what we have as a y. Then we've got log to the base 10 of t is like our x. So it's like nx plus log to the base 10 of k. So like we've got a straight line, which is what we have, so we've kind of managed to work it to there. So we can say that the straight line started, like, so therefore straight line started as the form p equals kt to the n, as the graph shows this relationship. So what we've done is we've kind of taken and expanded it, which gives us the relationship. Right, so for part B, we've been asked to find the value of n and k. So this is just straight line stuff. Like, as much as it's in a logarithm question, for this we've been given two coordinates and we've asked to find the equation of the line and state the values of n and k. Right, so we've not been asked for like anything that's out with what we've kind of done before. So we know that our gradient in this case is equal to the letter n, which is incredibly helpful because, you know, why keep our constant letters constant, right? Which is y2 minus y1 over x2 minus x1. Right, so we've got x1, y1, x2, y2. Right, so y2 is 13.45, y1 is 11.98, and then we get x2, which is 1.844, and x1, which is 1.6. In this case, it's probably going to be a calculator question, so we can use our calculators to work this out, and we get 6.0 0.02459, right? You could leave it as a fraction. It's a pretty horrendous fraction though. 735 over 122. Right, we'll leave it as a fraction, but so then we've got y equals mx plus c to work out our c, because we've not been told it, it's not given to us on the graph. So we have y equals mx plus c. So I'm going to use x1 and y1. So we get 11.98 is equal to 735 over 122 times by x, which is 1.6, plus c. So c is equal to 11.98, take away that 735 over 122 times 1.6, which when we do that in our calculators again gives us 2.3406. Keep going, right, round it to 2 decimal places because it kind of works because there's that 0 there. So 2.34 to 2 decimal places. Right, so we're almost there, I promise. Right, so that c that we found is equal to log to the base 10 of k. Okay, so k is going to be equal to 10 to the power of c. Just by rearranging the base of your logarithm becomes the base of your exponential, and rearranging, like swapping the letters around, we know that. So we get 10 to the power of 2.34. Okay, which is going to be 200 and something. 218.77616. So that's 218.78 to 2 decimal places. Okay, so that's what k is equal to, which we've been asked for. That's what n is equal to that we've been asked for, so there we go. That's the end of that homework. If you've got any other questions about any of the steps, or you're not sure kind of where what I've done comes from, just leave a comment and I will get back to you as quickly as I can, as soon as I notice the comments, which I have to say sometimes I'm not the greatest at, but I do check them, I promise. Okay, so hope that was all okay and that you understand everything.